Alrighty, everybody, welcome back to another episode of Subscribing to My Podcast. Because I have a new guest on the show every week, it's very difficult to get consistent viewership. So if there's one thing that you can do to support me and the guest featured on my show, is by interacting with the video. You can always unsubscribe later if you hate me or the content. Without further ado, here's your episode with Professor Steve Butler is a professor of mathematics here at Iowa State, but he actually teaches more than just the students here with his very large YouTube presence. Beard Meets Calculus. He has amassed nearly 2 million views on the videos where he does tutorials, he teaches stuff, he talks about juggling, amongst other things. But Steve, why don't you go ahead and introduce yourself and then tell the viewers some of the important things that they should know about you.
Okay, well, you already mentioned I'm a professor, but actually I'm a moral professor. And if you're not familiar, that's essentially a distinguished professor of teaching. So people said, wow, not only can he teach, that guy can really teach. Yeah. And so I do teach mathematics, and I teach a lot of calculus. So as a warning to the viewers, I will probably go off on lots of tangents today.
Yeah, and this is hopefully why you're here, because I think it's so interesting. One of the things that sets you apart from maybe the other professors that I've talked to is this internet presence that you have. And I think that's what a lot of people recognize you for. Just some of the establishing things that I'm pretty sure you're aware of, but if you're not, I would just love to hear your reaction to these things. But you have that video of you putting on the mask of your own face that has like 80,000 views. I don't know if you know this, that video got featured on YouTube Rewind, and that video has like 80 million views on it, which is so wild. And then beyond that, you've been doing calculus videos for a super long time. But I just, I want to hear like where this started, why you started making videos to help people with calculus, and then kind of like your origin story.
Well, in terms of the videos, I'd been thinking about it for a while, and I had to say, am I allowed to do this? And so I went to the associate chair for mathematics, said, can I get an answer? Am I allowed to record my lecture and to post it online? And I kept prompting, and they finally came back and they said, well, you're allowed to do it, but we just want to let you know, if you post it online, people from outside your class might actually watch it. Oh, that's how the internet works.
Yeah. Yeah.
Who knew? But the real reason this started is I had a graduate student. Her name was Kristen Hesse, and she had one class left to take. It was a class I was going to teach. But she also simultaneously needed to be in Minneapolis when I was teaching the class for the semester. She had a position that she was starting. So it's like, how can she take a class from way up there? I was like, well, let me finally pull the trigger, and I'll record. And so I started recording the lectures for that class. I said, well, if I'm doing it for that class, which was a graduate class, spectral graph theory, why not for my calculus class? And so I started doing it there, and I got better with time, and I've learned a lot. I've got a better setup, and I think students enjoy it. It's a good hobby,
Yeah. Do you spend a lot of time managing the videos, planning, like actually looking at maybe analytics or like looking at the way your videos, or is it more like a utility, like you just post these? Like how much time do you spend doing this other than recording?
Well, I don't do any advertising. And so in terms of the work, and it's mostly recording, I do, of course, I'm always interested in when people watch. And I can always tell when there's an exam.
Yeah.
Woo! So yeah, students really love the exams. And I think that what the most popular videos are, let me walk through an old exam from last semester. And let's take a look at those problems. Or here's a review. And I feel the best way to learn is to do problems. So it's just me doing problems for an hour or 2 hours. Or I have one video where I do problems for like 4.5 hours. There was just so many problems. Who can watch that? But that's all right.
Yeah, and so you kind of just post these, and then are these part of your, like when you're teaching a class are these in your Canvas, like amongst other things, or because I know when when other people are taking calculus classes, not with you, they're still watching your videos. But I guess I wonder when you're teaching if this is something that you do or talk about.
Well, I always record my lectures in some way, shape, or form. And so this semester I'm recording my lectures. And it's surprisingly cheap to do it. In terms of technology that you need, because I use the document camera, you need a cable to hook up a laptop to the document camera. It's $10. You need a lapel mic, $10. And then you can use your cell phone to record. And boom, you've got all the content. You just need to put it all together. And it doesn't take much to do it. Sorry, I should take notes here.
Yeah.
I feel like I know you're asking multiple things. I'm like, okay, but wait, I feel like I haven't answered all of the questions here.
No, you're totally good. One of the videos that you did that I mentioned earlier was the video of you putting on the mask, and that
very
obviously
popular in China, by the way. You talked about that video got 60,000, but it got millions of views, like in China and in India and
really.
Oh yeah.
What is that about? Do you think?
Well, I just think people. It was at a time. Pandemic, kind of almost peak pandemic, and people are like, yeah, they need somebody who can laugh at the absurdity of what the situation is. And no, I don't mind laughing at myself.
Yeah.
I don't try to take myself too seriously.
Which is probably a good thing. I guess what do you attribute to, I guess, like your popularity in these videos? Like, is there something that you feel like you're intentionally doing? Is there something that you feel like students are attracted to when it comes to these videos? Like, where do you think the views are coming from?
Well, I think there's a couple of things. One, it's access, because if it's 10 o'clock at night, and you need to get ready for an exam or something, a quiz the next day, you're not going to find somebody available to help you, very likely. And, the videos are always there. They're all organized. You mentioned Canvas before. That there's actually websites, calc1.org, calc2.org, calc3.org, calc4.org, and it's all systematically put together. So what is it that I do? Well, I think it's a combination of a couple of things. One, I tend to be sort of not very fast. I don't talk quickly. Most people will tell me, I watch the videos at like 1.25 or 1.5 speed, because then he sounds like a normal person. And so, it's a very calm. I don't try to ever be like, why can't you get it? It's like, I believe in you. You can get this. Because I do believe in people. I do believe they can get this. I do have humor. Sometimes it's very silly humor. There are certain things that people know me for, like le hôpital, le hôpital, mon ami, and people are like, oh yes, so like when they're thinking about le hôpital, they go, but it sort of helps emphasize and connect things together. And the other thing I'd like to say, and I hope this is true, but I'll claim it, since nobody's fact checking me here. I think that I'm pretty good at explaining things. When I was a undergraduate, I had a job, basically just one job as an undergraduate. I worked in a math help room, and I just spent thousands and thousands of hours explaining things to people, and I think that really helped me to develop a sense of like, okay, how do things work? How can I break things down in a very simple way that shows people, these are not complicated ideas. Math is, it presents itself as like, oh, it's very sophisticated, very complicated, very technical. And then you strip it away and you're like, that's just a simple idea. Why are you making it sound so complicated? And once you understand there are simple ideas that underlie what's going on, it makes it so much better and so much easier. And I think I've gotten good at explaining, here's the simple idea that underlies these beautiful mathematical truths.
Yeah, and I think those things are present. So it was funny you mentioned the the French quote that you're doing earlier, because I literally talked to somebody and they said that exact same thing. I was like, I'm gonna have Steve on, and then they just ran into that quote as well. So I thought that was really funny. So that is accurate. That there is a sense of humor in it. And then I know that with teaching things, you find that teaching something is the best way to learn something, and it's incredibly easy, or it makes things so much easier when you have to explain it in a simple way. And I wonder, I watched your video. It was the kind of overview of calc video, and then you talked about, like what calc is, why it's important, and these things. And so I guess I'm just, you explain things so simply and explain things so well in that video. But if you could just kind of walk through what calc is briefly, and explain it in the same terms that you did in that video, I think that was really interesting.
It's been a while since I've seen that video, but and I'm learning. I feel I'm finally starting to get the hang of it after all these years. And so, I mean, what is calculus? I would say there's really two big parts of calculus. And one part of calculus says, how are things changing? And the other part of calculus says, what's the total? And so a lot of questions people have about the world, anything that has a number, often boils down to one of these two questions or some variation of those two questions. They might say, okay, well, how do you understand how things are changing? Well, what's something we feel pretty confident about? Lines. I can understand lines. I know lines. And okay, what has changed? Well, it's like the slope is capturing that. And in particular, when we talk about change, it's always one thing changes with respect to another thing. And I should warn you, I'm going to probably end up giving a long lecture here if you don't stop me at some point.
No, you're good.
But, the change in y over the change in x, that's your slope. So it's how one thing changes with respect to another. So, okay, great. But the problem is the world isn't flat. There's all these curves out there. So if we understand flat things, the world isn't flat, what's our hope? Well, here's our hope. For a lot of interesting cases, a lot of interesting functions, we can zoom in. If you had like your cell phone, you have your pinch zoom, and you keep zooming, and all of a sudden, something that looks very squiggly looks less squiggly, and then looks fairly, maybe a slight bend, and then there's no bend at all. So in the nearby, everything's flat. And so that's calculus. It's like zoom in, now it's a flat thing, now we understand it. We use our tools from lines. Now what about the other thing I mentioned, like what's the total? Okay, how do we find that? And it's very curious. There's two sides to calculus. You always start with the first side, which is the differential calculus. How do you find rates of change? That actually came later in the history of mathematics. What's the total question? That beat it by a couple thousand years. And so how do you find the total of things? Well, again, what's really easy to find? Rectangles. I can find the total area of a rectangle, height, width, great, done. Well, most shapes aren't rectangles. So how do I handle a shape that's not a rectangle? An idea. Break it up into little tiny pieces. Each one of them is a rectangle. Now, it's not going to be a perfect, there's going to be little places where they don't quite exactly match, but I can use a lot of tiny rectangles to do a really good approximation. Now I add all those rectangles up. That gives me a really good approximation to area. But how do I do better? More rectangles. More and more and more. And so that's how you find totals. It's really about saying, look, take what you're trying to find, break it into small pieces, understand each piece, add it all up.
Yeah, and you had a really good application at the end of this, which was talking about like why it's important. And I think that that's not very intuitive to a lot of people when they think about math. They think about all these other subjects and they're like, "Oh, I get why we learned that. I understand how I can apply it." And then they get to this big calc machine and they don't understand it. And I thought you had a really cool perspective on that. So I guess like broadly, why is it important that people even study this, even if they're not going to use calculus in their lives?
Well, I would say that I think the most important thing that people get from the calculus sequence at Iowa State is to get really good at algebra, because you will not be able to survive without being good at algebra. We really push for it. But it really helps you learn how to think. And I think that's a very valuable thing in today's society. We are heading to a place where the kind of careers that people are going to have require you to solve problems. And it's going to be different from when you're in college. In college, you're like, well, I have a problem. Let me just look in the back of the book and say, there's the solution. And when we go out into the industry, there's a company I work for is going to come and say, we've got a problem. And I'm like, well, great. What does the back of the book say? Well, there is no back of the book. We have no clue what to do. You got to solve this problem. Oh, great. Now what do I do? Well, you apply your same skills. Problem-solving skills are important in any area. It's not just math. Anytime you have to solve a problem, it's how you approach it is very similar. Try to break it up into parts. Can you understand how to do each piece? How do you put things together? There's lots of the techniques that we learn in solving math problems. They spill over into many areas.
Yeah, and I think what do you do when people are like, how do you motivate students to focus on that when they're working on a problem that's kicking their butt and they just need to like, they're like, I don't care how good at problem solving I get. This is just hard. Like, how do you bring people back to that grounding of like, look, getting over this is a really important lesson for you to learn?
Well, I will say that math in general, it's a very challenging discipline. And one of the things that you have to learn is you have to learn to deal with frustration, because you're going to be frustrated. And I was at a talk once, and after the talk was done, they had a sort of some comments back and forth, and one person said, you know, mathematicians, they spend half their time banging their head against the wall. Why can't I get this? Why can't I get this? And then the other half, they spend kicking themselves. Why didn't I see this earlier? No! But there's this moment that happens between the two when you've been working really hard on a problem. And it's bliss when you finally get it. Pure bliss. I've never done drugs, but I think it's probably what drugs feels like. You know, so I can understand why people would want that experience. And the thing is, like, get it in math. If you're going to be addicted to math, that's a good thing.
Yeah, yeah. Well, I find it interesting because it's difficult to conceptualize going through 4 years of undergrad, doing calc, doing math, and then it's like, let's add on 6 more years of, doctorate research, and then let's go and teach it. So you've had decades of experience working with math, battling with math, teaching math, talking about math. How does that affect your mental health, your philosophies of life? Like, how do you live in this world so dedicated to math? How do you feel like it changes the way you live?
Well, I can tell you what my wife tells me. A lot of people might say, he's great with numbers, so he must be doing well. And my wife says, Steve, you're terrible with money. Like, yeah, that's true. It's a strange thing. I mean, it's I don't know if really this is interesting. I don't know if I see myself as a mathematician as much as I see myself as an educator now. I feel like that's the more important thing. And I still do math, and I enjoy math. And but for me, I think the most important thing that I can do is to help more people succeed. And I feel like as an educator, I'm still pretty new at this thing. And I'm getting better, but I have a lot of room left to grow. So, and there's a lot of gray in this beard, so I hope I get there soon. Worried about that.
How do you feel about that distinction between being a mathematician versus being a educator? Because I know that you've written papers, particularly on juggling, but you've also written on other things, and that's very interesting too, because you're discovering things, you're working on things, you're kind of heading the front of math research, but you're also being an educator. What does that distinction look like for you?
Well, it's always blurry, and why do people do research? Some people, of course, there's in academia, there's a phrase, publish or perish. Mm. And so it's like, well, I have to publish. And so I'll write and I'll create new mathematics. Is it great mathematics? Maybe. Maybe not. I mean, it's an interesting time in math. If you look at the amount of math that's been done in the last 10 years is more than the amount of math that was done in the previous 10,000 years. I mean, we are just having an explosion of mathematics. And, but in some sense, it's the golden age. Now, why do I say it's the golden age of mathematics? Well, because we have computers, and we can use them as tools, but they haven't replaced us yet, So we have these great computational tools, but they haven't yet taken over the job of math. Some people worry that computers might be doing that. Now, of course, as I warned you, I'm going to go off on tangents.
Please do.
So that was my tangent. Let me try to pull back. And mathematician versus educator. I mean, there's this desire to do new math, and I think that's a great way for young people to get involved. And a lot of people, of course, think, well, there's all these hundreds of years of math. It's going to take me a long time until I can get to something which hasn't been done before. But the truth is, not really. There's a lot of problems out there that haven't been done before that you can understand with a few weeks of study. And if you're, say, a math minor or you've had a few courses, you can get to unsolved problems fairly quickly. And I think math isn't some sort of ritual ceremony where we open the text and say, now today we will read the proof of Eratosthenes, yea, verily, yea. We're not out there chanting math theorems. Math is a human activity. We're doing things. We're proving things. We're explaining things. We want to understand things. And so it's a desire to know more. Now, some people, why are they motivated by math? Yeah, okay, some are motivated by applications. And a lot of good mathematics came out of physics, saying, hey, we're trying to understand this physical object, or maybe we have some sort of information about how wave propagates through systems, and we want to figure out what's the exact function that's capturing this, something. That's called applied mathematics. But some people they don't care. They say, look, I study math because I enjoy it. And there was a mathematician named Hardy. He was an English mathematician, very good English mathematician. And at one point, it was said that there were three great English mathematicians: Hardy, Littlewood, and Hardy Littlewood, because they just work so often together. And he's known, a lot of people know him now because he was also the person who discovered, and that's not a really good way to capture it, Ramanujan, and brought him from India to England. But he wrote a book, A Mathematician's Apology. He wasn't sorry about math. He's just trying to say, look, let me talk about what math is. And he said, I'll die a happy person knowing that none of the math I did was useful for anything. Well, turns out he did number theory. Now, number theory, okay, prime numbers. A lot of people know prime numbers. Why would you care about prime numbers? We knew about them, since the Greeks, several thousand years. So nobody cared. It was just fun. Then it turns out computers came along, and things like cryptography are based off of prime numbers. So all of a sudden, this very abstract, unusual thing became super important. And so mathematics, it has this ability to have sort of the unexpected applications. It's the same thing. There's this notion of geometry, and there's this Euclidean geometry, which says, hey, how do you describe things? And everybody's used to this Euclidean geometry, and there's this weird assumption that's made. Suppose you have a line. Suppose you have a point. Well, then there's a unique line going through that other point. That doesn't intersect with the first line you drew. All right, it's got to be true. There's got to be only one. Everybody knows that. Well, mathematicians were like, why? They tried for thousands of years to say, it's got to be obviously true, and they failed. And it turns out there was a reason they failed, because it doesn't have to be true. There are other geometries out there that exist where that's a false statement. And people thought, well, okay, that's just fun and games. Whatever. Let the mathematicians have their little playground. Einstein came along and said, that's the geometry you need to explain the universe. Whoa, who knew? So math has a lot of things going for it. Now, of course, education, I think, is also important. And if we're going to have mathematicians of the future, we've got to start bringing them up. And that's what I want to do, is I feel I'm going to be able to be more influential by helping people learn than by any theorem I find. There was one of my co-authors, his name was Warwick Delaney, and I only met him in person on one night. I went and visited his house. He actually had a brain tumor at that time. He passed away shortly after. And during our conversation, he said this, for most mathematicians, the most important thing that they'll ever do is not any theorem or result that they do. It's the teaching, what they do in the classroom. And I believe that. 100 years from now, yeah, there will be my papers that will exist because paper doesn't degrade very quickly. But I'm not going to be remembered for math. And I may not even be remembered for teaching. But the positive vibes I've put out into the world, I think will propagate for generations to come. And I think I'm making a difference. I hope so. Otherwise, I put way too much energy into this stuff.
I think all of your students would agree that you're doing a fantastic job, and you're doing something really important. Which is, I hope, I mean, judging by the amount of interaction you get, like this is qualitative or a quantitative, numbers that you can look at. I think it's incredibly fascinating talking about math like this because, like I said earlier, it's not intuitive necessarily. Like the layman doesn't look at math and they look at it just like you were saying, that like, oh, let them have their playground until it gets useful, until it gets something that's novel or new. But I guess as somebody like me who has never looked at math or studied math or anything like this, it's hard for me to even think about some of the more recent discoveries in math. It feels like nothing new has been discovered for the last 1,000 years or whatever, which is obviously untrue. But for the layman like myself, are there any exciting new things happening in math, even if new means 100 years ago? But I guess you might know what I'm asking here.
Well, for things that I care about, I always think lots of things are exciting. There's the Einstein that was discovered recently. Now you might say, wait, Einstein was born like 100 years ago. No, not that Einstein. It's a pun. Einstein, German for one stone, and there's this tiling that was famous for a long time, Penrose tiling, where you could tile the plane with these two shapes called the kites and darts. And you could do it in such a way that was non-repeating. And that has connections, by the way, to Iowa State in that about 13 years ago, I think, there was a Nobel Prize in Chemistry awarded to a professor at Iowa State University who studied, I want to say quasi-crystallography, but basically it was more or less saying, yeah, you have this weird thing of these non-repeating Penrose-type behavior happening in actual physical things. You know, it's really exists. Well, so the goal was, okay, you can create these non-repeating patterns with two shapes. What about one? And that was discovered, and that was done in the last couple of years, and people are very excited about it. And they have a couple of shapes that do it now. There are things such as, I just know the popular ones. I don't.
No, and that's okay.
Keep up with all the fun ones. The pentagon tilings. So you can, okay, you'll see. I have a bias towards fun mathematics.
Okay.
Given that I do math of juggling,
Yeah.
it's not too surprising I have a bias towards fun things. But things such as the tiling of the plane with pentagons, all the same shape. Now, a normal pentagon can't do it, but you can deform a pentagon, stretch sides, change angles, whatever you want, and some pentagons will do it. And the question is, well, okay, they found some that work, but they kept searching, and for a long time they hadn't found one, and then all of a sudden they found another one a couple of years ago. And then shortly after that, they were able to prove, and that's it. And I think it was 15 different pentagons that can be used to tile and fill up the plane, and that's been done. And so I'm picking on those examples because those are the ones that are easier to explain.
Exactly. Yeah.
And so lots of good math is being done, and I am honest when I say that this is a good time for mathematics, the golden age for mathematics. And it's, on the ground floor.
Yeah, which is wild to think about. I'm in a philosophy of science class right now, and we're just talking about like how science is done and like how discoveries and what that means. And it's really weird to look at scientific discoveries that used to be like gospel and then now are like, I can't believe they used to think that. Are there any like big mysteries of math right now that are really applicable that you feel like we might be solving soon, or like that they'll look back and they're like, dang, I can't believe these Neanderthals were doing math like this and they're talking about us? Like, is there anything about math going on right now that you can act as a time capsule to talk about?
Well, it's hard to predict, and I will say, it's been said that mathematicians, if you're going to gain immortality, math is one of the ways to go, because essentially once you've proven something, it's proven, and you don't look back and say, well, they didn't prove it. No, they proved it. Now, it doesn't mean what you proved is useful, but we will look at proofs that were done. I keep picking on the Greeks just because they were around a long time ago. But we look back at what they've done, and we still say, yeah, these are great ideas. Let's use them just like they used them. So, I would say, as compared to physics, every few decades we have to shake things up and be like, well, we have this standard model, and we have quantum mechanics, and we have this universe and gravity. It can't all be true. Something's got to give. And so we're just waiting for the next version to come along, and that's always going to be happening. We won't ever understand everything. That would be boring. There's going to always be more to do.
Yeah. Always work.
I I do a lot with juggling, or do some with juggling. And so as the saying goes, there's always one more ball. You learn to juggle 3 balls? Great. What about 4 balls? Well, okay. What about 5 balls? I'm like, okay.
How many can you juggle right now? Just out of curiosity.
Well, nothing, because there's no balls here. But no, I'm actually not that great a juggler. I can juggle 4 balls.
Okay.
I should work to 5, because then I'll be recognized as a juggler by jugglers.
Was that the metric? 5 when you reach 5?
Yeah, 5 balls is like, okay, you're a serious juggler.
I see.
4 balls, amateur.
Well, once you get 5, you can start working towards 6. So
exactly,
that's the next goal.
I do hold the distinction. Well, 2 people, me and my PhD advisor, hold the following distinction, in that the number of papers that we've written about math of juggling is greater than the number of balls that we can juggle. Now, she has the advantage that she doesn't juggle.
Oh, okay.
So
you're carrying a lot of water for that.
So yeah, whereas I can juggle 4 balls, so I've had to do at least 4 plus 1 papers.
So now you have to write more papers before you can upgrade to the next level of ball juggling.
I've actually already written more than that.
Okay.
I've written a lot of.
Yeah. Well, so right now, or I guess one of your interests we've established is juggling, but do you have like a mathematical interest that you're researching right now, something that really motivates you, some sort of mystery or something that you're looking at that can be relatively easily explained?
Well, I mean, I'm always interested about patterns, and I would say, I mean, right now, I'm not actively looking at any particular patterns, but for me, I think about juggling. There's different ways to describe juggling, and how can you exploit the different descriptions of juggling, and how can you see the interplay? And there's just sort of one of the things in math and science is that the greatest discoveries usually start off with the phrase, that's weird. Where you look at a lot of data and you look at a lot of examples and things are just, that's not what I thought it should be. Why is that? And let me spend time. And so I did some, over this past summer, I worked with some undergraduate students. There's something called the Research Experience for Undergraduates. It's a program funded by the government for many disciplines, math just being one of them. And they came and they worked with me, and we tried to count what are called prime juggling patterns. And so, okay, we kind of understand a juggling pattern, but what's a prime juggling pattern? Well, prime, in the following sense, is that if you watch the juggling pattern over time, it repeats, and you say, okay, well, at every throw, so that's our beat. You look at how will the balls land. Okay, so well, that ball will land in 2 beats, and that'll land in 4 beats, and that ball, that was really high, that'll land in 8 beats. And then you just keep track of that for every throw. And if those are all distinct, we call it prime. And somehow it says there's no internal repetition. Turns out it's hard to count those patterns. Now I know that because prior to 2015, the best result was for 1 ball. And the answer is for 1 ball, period end, 1 pattern. That was it. So what happened in 2015? I did another REU, and I had students come, and we figured out the answer for 2 balls. And it's messy. But you say, well, look, squint. Ignore the formula, squint. You say, well, yeah, there's this complicated expression, but it's basically, there's this peculiar constant, 1.329 ... times 2 to the n. And we can compute that constant. And that captures it up to an error, which is small, relatively speaking. So we know the answer for 2. And we're still working on 3. But we chipped away at it this past summer.
Yeah.
But it's hard. It's hard. You know, it's one of these things where I can only speak to math, where there's a lot of problems out there, and there's a lot of problems which are very trivial. You can figure it out almost instantly. And a lot of problems which are very impossible. And sometimes very impossible problems are easy to state. And then there's this very fine line where you have problems where it's just between trivial and impossible. And that's where you want to be. That's where you want to try to make progress.
Wow, I'm trying not to get too excited about how science works. But I do have a few more questions just about, I guess, like success in math. I asked you earlier a little bit about how math has affected your philosophies, how it's affected your life. Do you find that you've built like a higher sense of resilience because of so much exposure to math, or maybe even educating people? Do you find that you have a higher sense of resilience or anything?
Well, I hope so. I mean, I've certainly been tested a lot. And, well, I'll leave it at that.
Okay. But you're talking about at the end of that summary video of what calculus is. You're talking
Right.
about 4 prescriptive rules that you have for people when they're coming to calculus, and I thought one of them was particularly important. But could you kind of go, if you know what I'm talking about, can you kind of go through those
Honestly,
rules?
it's been so long. Go ahead, tell me what they are, and I'll
Yeah.
tell you if I agree.
Okay, so the one that I thought was most enlightening was do, not view, which is you should be practicing these things. You should
Right.
be operating these things as opposed to just kind of watching and then
Right.
internalizing, like you have to fail.
Well, you have to be active. I think a lot of people, it's easy to be passive. And, you're not going to learn calculus by slipping your calculus textbook under your pillow and laying it down at night and just hoping that the equations magically float up, because it doesn't work. So how do you learn calculus? Well, there's a saying, you have to fight it. You really have to go in and try it. And it's been a while. I think there's an expression, Jian Rong Yi Shui Nan, Chinese.
Oh, okay.
If you see it, it looks easy. Then you study it and you find out this is hard. When you watch an instructor, and I'm very guilty of this. I will make a problem look easy, and I'll say, well, why? What's this? Oh, here's this. It told us this, so that means we should do this, and then we do this and that, and it's just, wow, everything's flowing, everything's so obvious, and it gives a false illusion that it's going to happen to you. If everything's so obvious, like this math thing is trivial, I don't have to worry about it at all. And then you come to your first exam or your first quiz, and you're like, wait, I thought this was supposed to flow. What's happening here? And, math is a learned skill. It's just like, look at a violinist. They're amazing, but they didn't start out as amazing. They worked at it. And it's the same with math. You're not going to start out amazing. Hopefully you'll start out okay, and you work on it. And, of course, not everybody's going to become a mathematician, but everybody can become okay at math. I told this to my class the other day. I took an undergraduate drawing class when I was an undergraduate student. And the instructor came in the first day. He was taller than me, which is very unusual. And he had played basketball for some team. And he was from Africa, had this beautiful accent. And the first thing he told our class was, I do not believe you can all become good artists, but I do believe you can all become good draftsman. And I was like, oh, wow. I get what he's saying. He's saying, look, we're not all going to reach the pinnacles of everything, but we can all be good. You know, we're not all going to be excellent, but we can all be good. And it's the same with math. Like, look, not everybody who takes the calculus sequence is going to become a mathematician. But everybody who takes the calculus sequence can become competent in doing mathematics.
So then, do you kind of suggest that when people are preparing for exams, that they do more practicing than studying, per se? Or
Well, practice is studying. So, I mean, one of the things is you have to think about where are your weaknesses. You don't want to put your time and energy into things that you're already good at. If you're like, oh man, I keep getting these right, let me do another 20 of these because I just want the endorphins of like, look at me, I'm getting these right all the time. You really want to say, look, let me do problems that challenge me. And I mean, you have to learn how to study well. It's one of these things where there's skill sets. There's good studying and there's bad studying. And a lot of people are just like, well, it all comes down to quantity. You know, how much time am I studying? But there's also such a thing as quality. You know, how much are you getting out of the time you spend studying? And I do think there are people who study too much. I think there are a lot of people who don't study enough. But I also think that there's a lot of people who could benefit from better study habits. Now, for math, what makes good study habits is being active. It's doing problems. And, you know, you don't want to be stuck for an hour, but it's okay to be stuck for a couple minutes. The longer that you're stuck and the more that you push against that, and then when you finally go and look, you're like, oh, I can't believe I did that. That was, you won't make that mistake again. And one of the reasons I feel like I'm pretty good at math, I've made a lot of mistakes. And so I've learned to either avoid problems or catch mistakes as I make them. So it's not that I'm this amazing mathematician. It's that I've learned how to minimize mistakes. And hopefully, I'm helping the students pick up on those traits. I do think that there's a lot of people here at Iowa State who have a lot more potential than me. And I want them to succeed in that. I want them to be great.
do you have some specific tips or things that you do when you're doing a problem that kind of stop you from being more susceptible to making a mistake? Like, are there like, oh, okay, I'm going too quickly, I should slow down. Like, what tips do you use?
Well, I find that, speed is rarely your friend. And, so I don't tend to go very fast. But somehow at the same time, I said I talk slowly. But I've talked to my colleagues in the department, they're like, I don't know how you cover so much in your lectures. I can never keep up with that. I'm like, what are you talking about? I go slow. Oh my gosh, I got off on a tangent.
No. What tips and tricks do you use
tips and tricks
to stop yourself from failing or making mistakes?
Tips and tricks to stop yourself from failing and making mistakes. Well, number one, take notes, so you know what the question was. Well, I do think one of the things that you have to learn, one is you have to understand the problem. And sometimes I see people starting to answer a question without fully grasping what it is that they're doing. And this is not just students. I mean, I've seen faculty, brilliant mathematicians who are listening to a student ask a question, and before the student has finished asking, they've already started answering it, and I know that they're answering the wrong question. And this is not a dig on any current faculty.
Any names?
That faculty member is no longer at Iowa State, which is a shame because I love that man. He was a great man. But So make sure you understand what's being asked. That's an important thing. And okay, take your time. Look for mistakes. There's most of the mistakes I make nowadays are copying errors, just small things. And so it's easy to catch if you're thinking about, like, okay, did I write everything down right? Or, okay, does that seem reasonable? As you're thinking about problems, you start to think about all the problems you've done before. Why do we tell people to do problems? Well, we're asking them to sort of build up this reservoir of knowledge that they can tap into. Mathematicians aren't creative. There's Mark Twain had this quote, history doesn't repeat itself, but it often rhymes. It's the same with math. Problems may not be the exact same, but they're similar. And so you say, oh, I saw a problem like this before. I was able to solve it. And I did it by doing these steps. So let me start doing those steps. And another thing is to sort of know when to pause and say, this is snowballing out of control. I've seen so many students have their exams turned in. We're grading them. And there's this problem which should only take a couple of lines. And there's like 2 solid pages of work done. And we're looking at this and like, we can give them 3 out of 10 points. But they just spent so much time going in wrong directions. Well, they should have stepped back and said, something's not right. Let me think about what's going on. So you have to take your time. You have to, build up your reservoir of knowledge. You have to know what you're answering. And it's practice.
Sorry, go ahead.
No.
Sorry, you work in a relatively vulnerable set of college students, and that, like, obviously a lot of people really struggle with calculus. It's kind of the big bad wolf of classes that are offered here, amongst other classes too, in that they're relatively challenging, and that people often are more scared of getting a bad grade in this, or something along these lines. Do you interact with a lot of angry students, emotional students, anything like this? And then how do you go about interacting with students who are like this?
I mean, I've had people who are upset. It's challenging, and in some sense, it shows they care, which I appreciate the fact that they care. So I will say, I've had students break down in tears in my office. So I went and bought like 60 boxes of Kleenex tissues. And I just said, okay, colleagues, in case you need something for your office, calculus season is just around the corner. It's good to be prepared for when students come in. I think it's hard. One of the biggest challenges is I know that they want to succeed in the course and move on, and we want that too. But the biggest challenge that most students have is not with calculus. It's algebra. It's arithmetic. It's what they should already know coming into calculus. And in some sense, it's a wake-up call. Do you really know algebra, or did you know just enough to get by? And I think that a lot of times what separates the high-performing students from the low-performing students is just how well they're drilled in their basics. I sometimes say for differential equations, which I've taught many times in the last couple of years, that was basically all I did for about 2.5 years. I said, it's in an algebra class, just wrapped in a calculus candy coating, but it's all algebra. And you will succeed or fail based on whether or not you can do algebra. So I think the most frustrating thing for them is also the most frustrating thing for us. we know what they need. We want them to succeed, but they don't have the right skill set to succeed yet. And that's one of the things that we talk about. I was in a meeting this morning where we were talking about how do we make sure students are in the right class. We don't have an answer for that. I think if we could help students be in the right class, help them have the skills that they needed to succeed, I think calculus would be a very different experience for many people, if not most people.
Do you think that there's maybe something missing in the high school curriculum or things that are happening recently? Do you think this is a more recent phenomenon, or has, algebra always been?
I don't want to blame anybody. Not everybody's good at algebra in high school. I wasn't good at algebra in high school. I got a C or a D. I don't remember. One of those.
Yeah.
It wasn't better than a C. But I do think that there's been a trend. And we saw this pre-pandemic, that the students were not doing as well in our courses. I think the pandemic exacerbated the situation. We still have students who do great. And I taught at UCLA. It's a small community college out in California. And I look at those students. We have students just as capable, just as smart. We have amazing students here. So I don't want to make any indications that we don't have smart students at Iowa State. We do. We have amazing people here. We put the biggest challenge in education is not teaching the smart students who have the strong backgrounds and who do well. We spend our times, how do we help the students who don't have that strong background? And I don't want to come across as like, man, I just wish they wouldn't take the class, Why are they here? Yeah. We want to help you, but you have to be ready to ask for help. And I think that's hard. One of the biggest challenges that students have, how do they even know where to start asking for help? I don't know what to do. I remember there was this old TV show started in the 80s. You probably never heard of it. It's called The Simpsons.
Oh, yeah.
And
never heard.
Yeah, but there was one scene I remember where a character said, we've tried nothing and we're all out of ideas. And I sometimes think about, this describes some of my students. You should try things. It's okay to fail. I think fear of being wrong has really hurt people. It's okay to be wrong. You learn things by being wrong. You just have to learn to recover and to say, okay, I was wrong. What did I learn from that? Great, I learned something. Now let me try again. And I might be wrong again, but I'll learn from that. And eventually, I'll be right. So we have to learn to overcome these challenges, these mindsets. I think also, maybe not also, you could have phrased it in the following ways. You have to learn to be uncomfortable. And I don't think I can make calculus comfortable all the way through. At some point, you will feel uncomfortable. Even if it's at the point where it's like, my professor has this unhealthy fascination with the arctangent function. I'm not comfortable with that.
Yeah.
But, at some point,
yeah.
You'll be uncomfortable.
Yeah, and I think that's super important. I think when you're talking about learning how to problem solve, I think that's the most applicable function of math that I think people often overlook when they're cataloging why they're taking the classes that they are. They complain about taking calculus, and it's like, this is challenging you in such an important way that, like, it's hard to see that, especially if you're doing terribly. Like, it's hard to see that, but I think you articulated it very well on how important it is to be able to fail, to be able to recover, and to be able to come back up. On the back end of being a professor, what things are you kind of purposefully implementing? Like, what are some of the important things that you do as a professor to help engage students in this way, or just to be successful as a professor? What are you doing?
Well, I mean, it depends what you mean to be. How do you measure success as a professor?
That's true.
You
Well,
know,
I guess like effective at teaching the things that you want to do, and maybe some combination of also being enjoyed, appreciated, or whatever that means.
well, in theory, teaching is half my job, but during the school year, it takes up more than half my time, and that's okay. I can make up for it during the summer.
Yeah.
So don't worry, Iowa State, you're still getting your money's worth.
Yeah.
Okay. All right. Now that we have that out of the way, I don't want to get in trouble.
Yeah. Yeah.
So,
Yeah.
And in terms of what does it take to be good, I will say you would think that after having taught, I started teaching in August of 2001. That was the first time I taught a class. So it's been 23 years. I still, every time I approach a semester, it's like, let me try something. Maybe it'll work, and maybe it won't. And I'll see how it goes. And some of those things get passed down and become sort of a staple. The quizzes, like people know about the quizzes for calculus. Oh, we got those quizzes, and then we got these quiz banks. Well, why do they exist? Well, I was teaching Calc 3, multivariable calculus, and I taught it, and the students gave feedback. They said, the homework is terrible for preparing for exams. And I was like, well, yeah, they're right, because the homework is terrible. And we're not giving them the right skills and tools. So I said, well, how can I do that? Well, I have a whole bunch of problems because I've given exams in the past. Why don't I put together a weekly quiz, and then I'll say, look, here's the problems. Then I'll even give them the problems in advance. Just say, I'll pick 2 at random. And I started doing that. And the students, I think gained a lot from it. I mean, yes, it was a new stressor because he had to get ready for the quiz. But it turned out one of the things that was great about it was it gave them something to ask. Because now if they were stuck, they could say, I'm stuck on this one. I don't understand this. And like, great, now you have a question. Now you can come to your instructor. So that's an example of things which I've developed. So, I mean, the thing is, because I keep changing, I don't know what my final form is. And I probably will never get there. It's not about a destination, I suppose, is the way I would put it. Being an educator is a journey. And every time I teach, I try new things and I learn new things, including things such as, I should never do that again.
Was there anything in particular that you stopped doing because it just didn't work?
Yes. Let's see, should I say a safe for podcast one or not safe for podcast one?
Both. Let's go not safe for podcast. I'm very interested.
Oh, well, we're starting out with the not safe one, right?
Yeah,
okay,
yeah.
yes. All right. Nobody report me for what I'm about to say. So, I try to keep up a little bit with memes and language and whatnot, and just sort of pepper things in. And I sometimes don't keep up quite as well as I should. And so I was talking in multivariable calculus. There's this notion of level curves. All right, what's a level curve? Well, think of a topographical map. So if you've ever gone hiking where there's hills or mountains. Oh, well, okay, is this Iowa where there are hills? Then
Yeah, yeah.
you can have different elevation marks on that map, and so you're like, okay, all right. So we were talking about how if you're on a level curve, you have no desire to do anything. You're just going to laze around. Well, there was this phrase that I'd heard, and I thought, wow, this sounds like a great place for me to drop that phrase. And I said, yeah, you're just laying around, not doing anything. It's like, you're Netflix and chill. Class loved it. They laughed.
Yeah.
They're like, yeah. And then I mentioned this to somebody else, and they said, I don't think it means what you think it means. I was like, uh-oh. So, yeah, I found that out. So, yeah.
That's really good. Yeah.
But then there are things such as back when we tried moving calculus into a more coordinated state, so where it is today, we did an experiment and said, well, we'd like to have students do some group work. Okay, sounds reasonable. And so we'll have some homeworks, and we'll have 4 of them throughout the semester. You can do it as a group. We'll keep track of it. And we had them turn in the first homework. We graded it, and then we looked around and said, we're never doing this again. And we just sent out an email announcement, congratulations, everybody's getting 100% for the rest of the assignments for the semester.
Wow.
Just because we could not, we didn't have the capacity to do it. We knew in practice it was the right thing to do. And but in reality, when faced with like, how do we actually grade all these assessments? We didn't have the capacity, so we had to stop it. And there's a lot of things that we have to make tough choices on. As one of the professors down the hall was telling me, the way we teach calculus, everything that we do is wrong. Like all the theory about how you should teach, we're doing the exact opposite. And I was like, well, yeah, but given the resources, we're doing pretty well, right? To which they respond, yeah, given the resources, we're amazing. But, we're still doing it all wrong.
Yeah.
And there's a lot of things that would be great if we had more resources. We keep trying to figure things out. And even with calculus, we're having discussions like, okay, what can we do to make it a better experience for the students? And I'm interested to see where we go.
Yeah, I think that's a really cool historical look at some of the things and where it is today, and I'm really excited to see where you end up going in the future. But we're running up on a little bit over an hour for the episode, so I want to give you an opportunity to kind of close us out. If there's closing remarks you want to make about some of the things that you've said, if there's any advertising you want to do for maybe your channel or maybe some faculty, this is kind of your platform to close us out. However you see fit.
I don't need to advertise. I just do word of mouth. There's all these things. I was expecting so many other things when I came in here.
Mm-hmm.
Like ask about the history of where I was from. I came in with the story.
Yeah.
I hope you don't mind. You can edit this out. But the very first story about me and math goes back to before I was born. So when my mom was pregnant, she was very sick. The doctor told my parents, you should be prepared. Your son will probably have mental problems, and in particular, will not be good at math. So that's what my parents were told. And I will say that the first couple of years, they probably had some indications that the doctor was right, because I also had hearing problems, so my speech was delayed. I had speech impediments, all sorts of issues. But somehow I ended up here, So who knows? No matter what people say you're capable of, maybe you're capable of more. And I believe that. And I see myself as a cheerleader. I mentioned this to someone earlier today. Our role as calculus instructors, we're not there as tacklers trying to knock you down as you're running for the end zone. We're your cheerleaders. We're trying to cheer you on. We want you to succeed, and we hope people do. I believe in the students. To quote Tony the Tiger, they're great.
I could not think of a more inspirational way for us to close us. But thank you so much for being on the show and then talking about math and your story with me. I think it was really awesome.
Yeah, thanks for having me.
Okay.